what is the relation between the accelerations of these two blocks when the pulley itself is moving with some acceleration. That is what we are going to A1. So that is the acceleration of the block of mass 2 kilogram. So L, right? This ball should move upwards to cover a distance of L. So that is when it will lose contact, right? So that time we have to find. Time. The last class we did questions based on the pulley block system, but in all the questions we kept the pulley at rest. This pulley is not moving anywhere, right? It is kept at the same position, only these blocks are moving. When this block is moving upwards by a distance x units, the other block moves downwards by the same distance x. That means the accelerations of these two blocks are same, right? One is moving upward with some acceleration, the other block is moving downwards with the same acceleration, right? The directions are different, but the magnitudes of accelerations of these two blocks are same. But when the pulley itself is moving up or down by some acceleration, so what will happen? What is the relation between the accelerations of these two blocks when the pulley itself is moving with some acceleration? So that is what we are going to find, right? So here in this class we are going to consider all the cases where the pulley is moving, right? Yes. Now let us take the simple example. So the first example is the simple hardwood machine, right? A pulley and two blocks are attached to it. Now this pulley is at rest. Suppose that is the first case, okay, when the pulley is at rest. So when the pulley is at rest, so that is a simple case which we have already done. So when the pulley is at rest, this block is moving up by with acceleration say A1. The other block is moving with acceleration A2. Actually the other block is moving downwards, right, with some acceleration, same acceleration, but for convenience we take the direction fixed, right? So let us take the upward direction to be positive. So acceleration A1. The other block is moving up with acceleration A2. Actually it is moving downwards, that means A2 will be negative. But so what is the relation? This acceleration A2, so that equals negative of A1, right, because they are in the opposite direction. This is what we did in the last class. Magnitudes are same, so they have the same magnitude, but the directions are different. So this is a simple relation between the accelerations of these two blocks when the pulley is at rest. Okay, now take the next case. So the pulley is moving up, okay, with some acceleration. The pulley is moving up with some acceleration, say AP, right, the acceleration of the pulley. The pulley is moving up with some acceleration. So will the accelerations of these two blocks be same? No. So what we are going to do is we are going to observe the system. So sitting in the pulley frame, right? Suppose you are sitting in the pulley, right, and you observe that, then it appears as if these two blocks are moving with the same acceleration, one in the upward direction, one in the downward direction. That is only when you observe in the frame of that pulley, right? Now the pulley is also moving, so the actual accelerations of these two blocks are not same, but only the relative acceleration. The acceleration with respect to the pulley, right? The accelerations of these two blocks with respect to the pulley will have the same relation. Alright, so this is the relation. So A2 equals minus of A1. Okay, this is the relation. That is only when the pulley is at rest, but the pulley is not at rest. So we have to find, instead of the direct acceleration, you have to find the relative acceleration. How to find the relative acceleration? So we have to subtract the acceleration of the pulley, right? So A2 minus AP. Alright, similarly here also we have to subtract that AP because we are finding only the relative acceleration. So both are moving in the same direction, so we are subtracting. So this is the relation. So what is that? So AP plus AP. So 2AP equals A2 plus A1. So that gives you the relation. So AP equals A1 plus A2 divided by 2. So that's also, this is the relation between the accelerations of these two blocks. Okay, so the acceleration of the pulley is the average of the accelerations of these two blocks attached to the pulley, right? So you can even take this as the acceleration of the two blocks or the acceleration of the string, right? Acceleration of the string, this part of the string, right? So that is A1, the acceleration of that part of the string, that is A2. The average of these two accelerations will give you the acceleration of the pulley, right? So this is the relation, right? Yes, so this is one of the methods of finding the relation between the accelerations of these two pulleys, right? So let us understand this more by taking some more examples. Let's take this example. here the string is connected to a block, but the other end is fixed to the ground, right? Now we have to find the relation between the accelerations of the pulley and the block. All right, yes. Now the pulley goes up by some distance, say x units. Now what is the distance covered by that block? So the block also goes up by what distance? Is it the same distance? Okay, it is not very clear. So what do? Let us take the pulley, right? The pulley is going down by a distance x. Now when the pulley goes down by a distance x, that means the string becomes slack, right? So it gets slackened. So that means, so to compensate that, that block goes down by what distance? The pulley comes down by a distance x, that means the slackened part of the string. So that has length 2x, right? X plus x, 2x. So that distance is covered by that block, right? The block goes down by a distance of 2x, not x. So when the pulley comes down by a distance x, the block goes down by distance 2x. That means the block has acceleration twice the acceleration of the pulley, right? So both move in the same direction. So this is the relation. So that is one of the methods of doing it. So the acceleration of the block, so that is A. So that equals 2 times the acceleration of the pulley. So this is one way to do it, right? Directly we can do it. So when it moves by certain distance, okay, when the pulley moves by certain distance, the block moves by what distance? So the acceleration also is proportional to that value, right? So pulley goes down by x units, the block goes down by 2x units. So the acceleration of the block is 2 times the acceleration of the pulley. Okay, now we can also do by, you can directly write it, or we can also do this by that average method, right? Yes, now let us find the pulley, right? The acceleration of the pulley. Now what is the acceleration of the string attached to the block, that side? So that is acceleration A. A is the acceleration of the block. That is the acceleration of the string, that part, that of the string. What is the acceleration of this part of the string? This part of the string is attached to the ground. That means its acceleration is 0, because that is stationary, right? So the other end is not attached to a moving object. It is attached to the ground. So that means the acceleration of this part is 0, right? So that means if you use the average method, the acceleration of the pulley, that equals the average of the two sides, right? The block on that side and the string on this side. So what is the acceleration of the block? That is A, plus this side the acceleration of the string, so that is 0, right? Because it is not moving, it is attached to that ground, right? That means the acceleration is 0. So A plus 0 divided by 2. So this gives you the relation. So the acceleration equals 2 times the acceleration of the pulley. So that's all, right? This is the relation. So this way also we can find it, right? See, both the methods are important, right? So this average method, sometimes, so depending upon the question, we can use the method accordingly, whichever is easier for that particular situation. So the acceleration of the pulley in the middle is the average of the acceleration of the two sides. Two sides what? One side is the block, or that side of the string, and this side of the string. So they have average acceleration, this one A plus 0 by 2. So this is the relation between the acceleration. Okay, so let us take another example. Here we have two pulleys, one of which is a fixed one. The pulley on the left is connected to the ceiling. So that is a fixed pulley whose acceleration is 0. The other pulley is a moving one, right? What is the acceleration of that pulley? That pulley is directly connected to the block A. So that means these two move together, right? When the pulley moves up by a distance of x units, the block A will also move up by the same distance. That means the acceleration of that pulley and the block A are equal. So the pulley and the block have the same acceleration. But what about the block B? The block B has acceleration what? So is it same as the acceleration of A? Now we have to find the relation between the acceleration of the block B and the acceleration of block A, right? Yes. Now what we do? We will do this question by 4 methods, right? The first method, so that we are familiar with already. So the block A or the pulley connected to it moves up by a distance x, right? So x units. Now then the string becomes slack, right? What is that slack part of the string, right? That has length 2x, right? Because when the pulley moves up by a distance x, so this x plus x, 2x is this portion, right? So that is the slack. Now to compensate that, the block B has to move down by a distance of 2x. That means when the block A or the pulley moves up by a distance of x units, this block B moves down by a distance of 2x, right? So 2x is the distance covered by the block B, when the block A covers a distance of x units. That means the acceleration will also have the same relation. The acceleration of B is twice the acceleration of A, right? So that is one of the methods. So we don't need to do any calculation, directly we can write, right? So the acceleration of A and the acceleration of B are related. So that is method 1. Alright, so this is method 1. So what do we do? So just use the displacements, right? So the displacement of A and displacement of B are related. What relation? The same relation applies to the accelerations also, right? So this is the method. So when the block A okay, moves by a distance x, then block B moves by a distance 2x. So this is simple observation, right? We just observe this. So when A moves by distance x, this moves by distance twice of that. So that means the acceleration of the block B is twice the acceleration of the block A, right? So that is the relation between these accelerations. Okay, so this is one of the methods of finding the relation between these two objects. Okay, yes, so this is one of the methods, but we will call these methods by some names so that we can easily refer, right, later on. So this is the first method, we call it by some name. So what can you call it? So displacement method, right? Using displacement. Okay, so this is one of the methods which can relate the acceleration of the objects involved in the question. Okay, yes, that is done. Okay, now we'll also do this question by another method. In the second method, we make use of the lengths of the parts of the string, right? See, that length is taken as L from the ceiling to that pulley, right? First pulley, right? So that length is taken as L, right? That is a constant, right? L is a constant, that length is fixed. Now you take this portion to be between these two pulleys, right? That length is taken as x. That means that side also parallel. That is also x plus x, and also this portion, okay, of the string. So that has length y. So the total length of the string, so that is y plus x plus x plus L, right? So that curved part, right, around that pulley, so that is not considered, right? Because anyway that is going to be constant. The curved part, right, above the pulley or below this pulley, so that portion is not considered. Y plus x plus x plus L, this is the total length of the string, okay? But that is also a constant, right? Total length of the string is always constant. Wherever the string moves, the length of the string is always constant. So y plus x plus L is constant, right? So this is the second method. Yeah, this is method 2. Okay, yes, now what do we do? So this total is constant, y plus 2x plus L is a constant. Okay, now what do we do? So we differentiate this. Okay, if you differentiate this, so what is the derivative of this? So dy by dt, okay, so dy by dt. So similarly this one plus 2 dx by dt, L is constant, okay, whose derivative is 0, so that equals 0. Okay, now what you do? What is this dy by dt? What is this dy by dt? As y increases, the block B goes down. That means the rate at which y changes, that is the velocity of the point B, right? So y increases, so B displaces. So y is actually the displacement of the block B. So that means as the rate of change of y, that is dy by dt, the rate of change of y is the velocity of the block B, right? So dy by dt is the velocity of the block B, the velocity of the block B, right? Yes, similarly as y increases, this A, right, if x increases, right, the block A goes down. So that means the velocity of A is the rate of change of x, right? That is dx by dt. So dx by dt is the rate of change of that block A, right? So that means we can write it as plus 2 times the velocity of the block A. So that equals 0. Okay, yes. Now what do we do? You can again differentiate. So if you differentiate again, if you differentiate velocity, that will become the acceleration, right? The acceleration of B equals, okay, that side if you can take it to, so 2 times the acceleration of the block A. So that's all, that is the relation, right? Negative sign because one of them is going up, the other one is going down, right? So negative, but if you just want the magnitudes, so the acceleration of B equals 2 times the acceleration of A, right? So that's all. So this is the relation between these two accelerations. So this is one of the methods of finding the relation between the acceleration, making use of the constant and the variable part of the string, right? Length of the part of the string. So that X is the displacement of the block A and Y is the displacement of the block B. If you differentiate 2 times, we get the relation between the accelerations. So this is also one of the methods of finding the relation. So let us call it by some name, right? So this method, so we can call it some differentiation method, right? Because we are differentiating, you can call it differentiation method, or we make use of some variables, so we can call it a variable method, just a name so that we can refer to it later on. So variable method, okay. So this method, see, mostly we don't use this method, right? So just know this method, but in most of the questions we will try to use the other method, because for this method, you see, so you have to do all these calculations, okay? Just to avoid this, so we can, if possible, we can use the other method, right? So this method is last resort, right? If nothing works, we can use this variable method. All right. So this is the relation, acceleration of the block B is twice the acceleration of E, right? The magnitude. All right. So this is one of the methods of finding the relation between these two accelerations. Okay. Yeah. Next method is using the average, right? That you are already familiar with. Let us find the acceleration of the pulley that is attached to the block A. What is the acceleration of that part of the string and the acceleration of this part of the string? So the average is the acceleration of the middle one, that is the pulley, right? Yes. Now what is the acceleration of that part of the string? That part of the string is directly attached to the ceiling. That means its acceleration is 0, right? Because that is stationary, that is fixed. That means the acceleration is 0. So let us use the average, okay? So this is the next method. So method 3, okay. So what is the acceleration of the pulley or the block A, right? The acceleration of the block A or the pulley. So that equals the average of the acceleration of that part of the string. So that is 0. 0 is the acceleration of that part, plus the acceleration of this part of the string, right? The part of the string on the left of the pulley. So what is that? But that part is directly connected to the block B, right? So that string only is attached to the block B. So the block B has same acceleration as the acceleration of the part on the middle, right? Right. So that is the left side of the pulley attached to the block A. We have the string having acceleration same as the acceleration of the block B only. So that means that acceleration is 0 because it is attached to the ceiling. So acceleration is 0. But this part of the string is attached to B. So its acceleration is acceleration of B only. So that means 0 plus acceleration of B divided by 2. Okay. So that's all. We just take the average of the two parts of the string. So middle one has the acceleration, just the average. That's all. So this gives you the relation. So that is acceleration of B equals 2 times acceleration of A. So that's all. So that is the relation between these two accelerations. Okay. So this is one of the methods of finding the relation between the accelerations. Okay. So we can call this by the method to the average method, right? Because we find average. So average method. Okay. So this is one of the methods of finding the relation between the accelerations of the two blocks in the question. Okay. Yeah. In the next method, we make use of the tension in the string. See, this method is very important because in most of the cases, we can use this method. Okay. So this is our method number 4, right? So method 4. So here you have to remember one formula. Alright. So we have to remember one formula in terms of the tension on the string. So that is this one, sigma, right? The summation of this T multiplied by A, right? Or more generally, see this T vector dot product with the A vector. This total equals 0, right? So the concept behind that we are not getting into. Actually, it is the work done by the tension force, right? Work done by the internal force is 0, right? Total work done. So that is the tension multiplied by the displacement. you differentiate 2 times, you will get acceleration, right? So tension by, so total work done is 0. But work done related things we are going to do in the next class only. So but we will use this only as a shortcut, right? Concept behind this is not for us now. Okay, so later on we will see what this means actually. Okay, for now, tension multiplied by the acceleration for a particular block. Similarly, you find it for the other block also. The tension acting on that block, multiply that by the acceleration. Similarly, for the other block, you add all that, that total must be equal to 0, right? So this is the idea we are going to use, right? So this is important, right? Okay, right. Now this is dot product, that means direction is important. But in most of the cases, the tension and acceleration will have the same direction or in the opposite direction. So when tension on that block and acceleration of that block, they are in the same direction. No need of dot product, simply multiply the magnitudes, that's all. Tension multiplied by the acceleration, that's all. Sometimes tension will be in the direction opposite to the direction of the acceleration. In that case, you put a negative sign, that minus of the magnitude, right? Multiplication of the magnitude. Okay, only these two cases. Okay, so same direction, just multiply the magnitude. Opposite direction, negative of that. Okay, so that's all, right? So this is the idea we're going to use for most of the questions. This is the important method, right? See, you tell me what are the forces acting on the block A, right? Or what is the tension of that string which connects that pulley to that block. See, this is one string only. This is one string which is going over these two pulleys. So that one string has tension, say T. T is the tension. Okay. Now that means what is the tension on the block B? Tension on the block B. So that is T only, right? So it is like this. So I'm writing this summation. So that means the tension on the block B, tension on the block B, and then acceleration of the block B plus tension on the block A dot product with the acceleration of block A. That is the meaning of this summation, right? Summation means what? You have to add all the similar values. So this equal to 0. What is the tension on the block B? That is T. That is the tension on the string. So that is T. So T multiplied by the acceleration of the block B. Okay, so that magnitude is AB only. So AB, okay, acceleration. Okay, but are the tension and acceleration in the same direction or they are in the opposite direction? So the tension is acting in the upward direction. What about B? B is moving in the upward or downward direction. So we don't know, right? So one of the directions. Suppose B is moving in the upward direction. Okay, B moving vertically upwards. So that means tension is also in the same direction. That means positive. So no problem with that. Next, what is the tension acting on the block A? See, this string has tension T. That means that part of the string has tension T, and this part of the string also has tension T. So that means the T plus T, 2T is the total tension acting on the block A, right? So the block A, the total tension is 2T. So that is 2T. What about acceleration of the block A? So that is acceleration A. Okay, so that's all. So positive or negative. Now the tension is acting in the upward direction. The block A is going in the downward direction because we have assumed that the block B is moving upwards. So that means A must be moving in the downward direction. So that means the tension in the upward direction, the acceleration in the downward direction. So they are in the opposite direction. So we have to write minus. Okay, so that is equal to 0. Okay. That's all. So this will give you our required relation, right? So what is the acceleration of B? So that equals 2 times acceleration of A. Okay, so that's also, that is the relation. See, this is important, right, to make use of the tension to find the acceleration, right? So what do we have to do? You find the tension on each block of that question, right? Whatever is the number of blocks given, so you find the tension on each block, multiply that by the acceleration, this sum, right? So that will give you that value is 0. So using that we can find the relation between the accelerations of the given blocks. Okay, so that is one of the methods of finding the relation between the accelerations of the given blocks in the question. Okay, this is only the relation between the accelerations of the two blocks, only the magnitudes. Magnitude of the acceleration of B is twice the magnitude of acceleration of A, right? Because we have assumed that one of the blocks B, right, the block B is moving in the upward direction and A is moving downwards, right? So then we get only the positive values. But initially, suppose you don't know which block moves in which direction, right? Then you can fix one direction. We assume that both the blocks are moving in the upward direction, but that is not true, right? But we assume that these two blocks are moving in the upward direction. then you will not write this minus sign, right? Because both of them, the tension is in the upward direction, the blocks are also moving in the same direction, so no negative sign, plus only. So in that case, what will you get? So we'll get T acceleration of B plus T acceleration of A equals 0, right? 2T. So in that case, what will you get? The acceleration of B equals minus of 2 acceleration of A, right? So this time we are getting negative sign because we had assumed that both the blocks are moving in the upward direction. So that is not true. One of them is moving in the downward direction. We don't know which one. So obviously the acceleration of one of them is negative of the acceleration of the other. But this takes care of the direction also. But here no direction. Because we have assumed the correct direction, you only get the relation between the magnitude. Okay, it doesn't matter. See, for these two block system, it is very easy to guess the direction of motion of the object, right? One of them is upward, one of them is downward. Even though we don't know which one is upward, which one is downward, one of them is positive, one of them is negative. Okay, but sometimes it is very complicated. When there are more than 2 or 3 blocks, in that case, you assume that all the blocks are moving in one direction only, upward direction. You will get the sign accordingly, right? Once you use this relation, you will get the sign of the acceleration according to that situation. So don't you worry about the direction of the motion of the object, right? Yes. Now, so this is one of the methods of finding the acceleration. Okay, yes. So let us name this, right? So we will call this, what can I call this? Work done method, or okay, we'll call it tension method. Okay, tension method. So this tension method is what we use for most of the questions, right? So just to make it easier, right? The other methods sometimes get more complicated, right? So especially when there are more than 2 or 3 blocks. So this method will be relatively easier compared to the other methods. Okay, yes.
Which method should I use in questions?
See, that depends on you. Whichever method that you feel is convenient, you can use that. But usually we try to avoid that variable method, right? Taking x, y and all, right? But still we learn that method because sometimes the other method might fail, right? So we have to have one method which works in many cases. So that method we try to avoid, right? We don't want to do a lot of calculations. But mostly we use this tension method, okay? And otherwise we can use that first method, right? That is the displacement method. If one block moves by some distance, the other block moves by what distance, okay? That will give you the direct relation between the acceleration. But that method doesn't work in most of the cases because only we have 2 blocks, so directly we can relate the acceleration, but that is not possible in many cases. When there are more than 2 blocks, so displacement method will not work, right? So don't rely on that method, okay? But that is why we learned this method. So in most of the cases we use this tension method only, okay? So let's be thorough with this particular method which works in many questions, okay? Yes. The acceleration of the block of mass capital M given in the figure is. Here we have a force F acting on the block of mass small m in the horizontal direction. We have to find the acceleration of the other block. See, here we have 2 pulleys, one of which is a fixed pulley. The other one is a moving pulley. So the accelerations of these 2 blocks are not same. So first of all, we have to find the relation between the accelerations of these 2 blocks using one of the methods that we have done just now, right? Yes. Let us use the displacement method. If the block of mass small m, right, moves by a distance of x units, right, in the horizontal direction, x units to the right. Now the string becomes slack by what length? So the length is x plus x2x, right? The 2x portion of the string becomes slack. So then to make it taut, that mass capital M moves down by the same distance x. You understand? So if this block of mass small m moves by distance x, the block of mass capital M moves down by a distance of 2x, right? Just to make the string taut, right, becomes loosened, right, by a length of x plus x2x. That 2x distance is covered by that block of mass capital M. So that means when this moves by a distance x, that block moves down by a distance of 2x, right, twice the distance. That means the acceleration is also related by the same multiple, right? See, the acceleration of the block of mass capital M is twice the acceleration. So this is the relation. So the acceleration of this capital M, that is twice the acceleration of small m, right? Because the displacement is related by the same quantity, right? So the acceleration of that block is twice the acceleration of this, okay?
Can't we use the tension method?
Mostly for 2 block questions, this is the easier method, right? You can also use the tension method, right? Yes. So the tension method, what is the tension acting on the block of mass capital M? So that is T, tension on the string only. So T in the upward direction, and the acceleration can be taken as acceleration AM, right? So that means T multiplied by the acceleration of M. What is the tension acting on this block? That is 2T, right? T plus T, right? Two strings, right, attached to that. So T plus T. So 2T is the tension acting on the block of mass small m. So that means plus 2T AM. So that equals 0. So that gives you the relation. So dividing by T, AM equal to actually negative, but we want only the magnitude 2 times the acceleration of M. So any one method, right? So either you can use this method or this method. So you can get the relation. So one of these blocks move with twice the acceleration as the other one. Okay, done. Now we have to use our equation, right? Now let us write for the block of mass small m. What are the forces acting on the block? Tension in this direction, 2T, not T. So T plus T, 2T in this direction, and F is acting in the opposite direction. So that means, so we get 2T, right? 2T in this direction and minus F in the opposite direction. This is the total force. So that must be equal to mass times the acceleration. So acceleration AM. Okay, so done. Now similarly, we will write for the other block also, right? Mass M. So what are the forces acting on this block? So now the gravitational force is acting in the downward direction, so mg. Now the tension is acting in the upward direction, so minus T. That equals the mass times the acceleration of m. Okay, yes. Now we know the relation between them. What is acceleration? Capital M. So that is same as 2 times the acceleration of this, right? So that means this can be written as 2 capital M acceleration of m. Okay, so that's it. We just solve the two equations to get our required answer. I think we don't need this T, right? We have to eliminate T. How to eliminate T? So find T here and substitute. Okay, so or we can do one thing. So this is our equation number 1. This is equation 2. So we can add this equation with twice of the second equation. So first equation can be added with 2 times the second equation. So that gives you, so 2 times mg minus F equal to, so this is multiplied by 2, so 4m am. So here 4m, this is added, so plus m multiplied by am. Okay, yes, so that's all. So this will give you our required acceleration am. So that is 2 mg minus F divided by 4m plus m. So this is the acceleration of the block of mass small m, right? But we need the acceleration of the other block, right, of mass capital M. That is twice of this, right? Acceleration of this equal to 2 times this acceleration. That means, so that can also be found am equals, so 2 times this. So that is 2 multiplied by 2 mg minus F divided by 4m plus m. Okay, or you can multiply inside 4 mg minus 2f divided by 4m plus m. So that is the acceleration of the block of mass capital M in the downward direction, right? So that is the answer. The acceleration of the block of mass 2 kg given in the figure is, here we have 3 blocks and 3 pulleys, 2 of which are moving pulleys, right? The pulleys on the right, they are moving pulleys. Other pulley on the left, that is a fixed pulley, right? So what do we have to do? We have to first find the relation between the accelerations of all these 3 blocks. Okay, yes. Now let us take the accelerations to be a1, a2, a3, right? The block on the left, that is acceleration a1, and similarly a2, a3. Initially we don't know whether these blocks move up or down. The direction of acceleration is not known. So we assume that all the blocks are moving up, right? So we will get the sign accordingly. If one of the blocks is moving downwards, the value of a1 or a2 will be negative, right? So let us take all these 3 blocks to be moving in the upward direction, having acceleration a1, a2, a3. Yes, now this pulley in the middle, that is directly connected to the block of mass 2 kg. That means they move together always, right? If this block moves up, the pulley will also move down with the same acceleration, right? So that means the acceleration of the pulley in the middle is same as the acceleration of the block of mass 2 kg. Okay. What about the acceleration of the pulley on the right? So that is also directly connected to the block of mass 3 kg. That means the acceleration of that pulley and the block below that, so they have the same value. Okay, yes. What about the acceleration of the other block? Okay, so let us take the acceleration. Let us use, we have the different methods of finding the relation between the accelerations. Let us first use the average method. Okay, yes, the pulley on the right, what is the acceleration of that pulley? So that is a3. Okay, but what about the acceleration of the other pulley? Let us take, see, we use the average method. That means the string on the right of that pulley, so that has acceleration 0 because that is connected to the ceiling, so that is fixed. That means pulley on the right, the string on the right of that pulley, so that has acceleration 0. What about the pulley, the string on the left? See, the average is a3. The average is a3, right? This acceleration and that acceleration, that is a3. See, remember, so that pulley is directly connected to the block of mass 4 kg, but still the acceleration of that is not same as the acceleration of the 4 kg block because they are connected via the moving pulley, right? Not fixed pulley like the other case. So we have to take the average. See, the average is a3 because the pulley on the right, that is the middle one, so that has acceleration a3. So that side we have 0. So this side it should be 2a3, then only the average will be a3, right? 2a3 plus 0 divided by 2, that is the average, that is a3. So that means the string on the left of the right pulley, so that has acceleration a2a3. Okay, yes. Similarly, now let us take the middle pulley. So middle pulley has acceleration same as a1. So a1 is the acceleration of the middle pulley, right? So now take the average. On the left we have this pulley 4 kg which has acceleration a2. And similarly, on the right of that pulley, we have acceleration 2a3. So the average of these two is the average of the middle one. Okay, so that means if you use this average method, right? So for that pulley, okay, in the middle, that pulley in the middle, so that has acceleration minus a1. I'm taking minus a1 because so that is moving in the downward direction. The other objects are moving in the upward direction because the block is moving in the upward direction, so the pulley connected to that is going downwards, right? That means minus a1, so that equals the average. What is the average? The pulley on the right, that has acceleration 2a3, and the pulley, the string on the left, so that is connected to the 4 kg block, that has acceleration a2, so plus a2, okay, divided by 2. That's also, that is the relation between the acceleration, so that is 2a1, yeah, plus a2 plus 2a3, so that equals 0. So this is the relation between the accelerations of all the 3 blocks. Okay, done. Okay, it can also be done by the tension method, okay, or it can be done by the tension method. So what is the tension method? So let us find the tension acting on all these 3 blocks. All the blocks are moving in the upward direction. The tension is also acting in the upward direction, right? Yes. Now let us take the tension on that rope on the right. Okay, the string on the right, that has tension T, right? The complete rope has tension T. Okay, that means what is the tension acting on the block of mass 3 kg? That is 2T, because T plus T, that is 2T. So 2T is the tension acting on the block of mass 3 kg. So similarly, what is the tension acting on the block of mass 4 kg? So that is T only, because that is the same string. So T. Similarly, now what is the tension acting on the 2 kg block? That is 2T, because so that middle pulley, take the middle pulley. So the two sides we have tension T plus T. So that is 2T. 2T is the tension on the other string. So that is connected to this block of mass 2 kg, that has tension 2T. So let us multiply the tension with the acceleration of the first block. So that is T, 2T, multiplied by the acceleration is A1, plus the next one, okay, middle block. So that has tension T, and then multiply by the acceleration. So it is T, A2. And then the last block, so that has tension 2T multiplied by its acceleration A3. So that equals 0. Okay, if you divide by T, you get 2A1 plus A2 plus 2A3 equals 0. So that's also, this is the relation between the accelerations of all the 3 blocks. Okay, so either way, you can either use this method or this method to get the relation between the accelerations of these 3 blocks. Okay.
The displacement method doesn't work here?
You can also do by the displacement method, but that is very complicated when you have more than one moving pulleys. Here we have 2 moving pulleys, so don't do that method. Okay, you can do that, but it is very complicated. When you have only one moving pulley, so the easiest method is the displacement method. Directly we can write the relation between the acceleration, but we have 2 moving pulleys here, so you can follow one of these methods. Okay, so the easiest method is this one, right? The tension method. Right, so no confusion, right? Directly we can get the answer. We can find the tension on each block and then we can use this formula, right? So this is the easiest method. So if you have only one moving pulley, maybe you can use that method, right? The displacement method. Okay, yes, now we've got the relation between the accelerations. Now we can write the equation for all the three blocks. Okay, now what are the forces acting on the block of mass 2 kilogram? Okay, so that is the first one. So the 2 kilogram block, so 2 kg block. So what are the forces? The tension is acting in the upward direction, 2T, not T. So 2T tension is acting in the upward direction, and the gravitation force in the downward direction, so minus 2G. So that equals mass is 2 multiplied by the acceleration is A1. Okay, so that is for the 2 kg block, and the middle one, so that is 4 kg block. Yes, so again tension. So what is the tension acting on that block? So that is T only, T, and then gravitation force in the downward direction, so that is T minus and mg, so that is 4g. That equals mass times the acceleration, 4a2. Okay, similarly the next one is the 3 kilogram block. So the tension is 2t. 2t is the tension on that block, so 2t minus 3g. So that equals 3 times the acceleration a3. Now we've got three equations. We have to solve them to get the values of these accelerations, right? We already have a relation between this a1, a2 and a3. We can use that. See, we know that, say, 2a1 plus a2 plus 2a3. So that equals 0. But we got the values of a1, a2 and a3. That can be substituted here. What is 2a1? So that is 2t minus 2g plus, so a2. So what is a2? So this divided by 4, so that is t by 4. Okay, t by 4 minus g, right? That is a2. And similarly 2a3. So what is 2a3? So multiply this by 2. So this is 4t minus 6g. Okay, divided by 3. So this equals 0. Alright, simplify this to get the value of t. So t, if you take out, so it will become 2 plus 1 by 4. So here, plus 4 by 3, so that equals g, so 2g minus 3, so minus 3g minus 2g, so that is 5g. So this gives you the value of t, so that equals, so this is 12, so 24 plus 3, 27, 27 plus 16, right? So that is 43, so 43t, right? 43t divided by 12 equal to 5g, so 12 times 5, that is 60g divided by 43. So that is the tension T. So once T is found, we can substitute this here to get the value of A1, or if you want A2, we can substitute it here. So we can find all the three accelerations. Okay, now we want the acceleration A1, right? Substitute it here. So we know that A1 equals T minus G. So that means it is 60G divided by 43 minus G. So that is the answer, right? 60 minus 43. So that is 17G divided by 43. So that's all. So that is the acceleration A1. So that is the acceleration of the block of mass 2 kilogram. So that is the answer. Find the accelerations of the blocks and the pulleys given in the figure. Here also we have 3 pulleys, 2 of which are moving pulleys and 1 is a fixed pulley. We have to find the accelerations of these pulleys and also the blocks. Now here these pulleys are named P1, P2, P3. This pulley P2 is attached to the mass M2 directly, right? So that means these two objects move together, so they have the same acceleration. The acceleration of the pulley P2 is same as the acceleration of the mass M2. Okay, but what about M1? So M1 is not attached to the pulley directly, so we have to find the acceleration separately. So we have to find the relation between the accelerations of these objects first. See here, this is just one string, right? Just one string which connects all these objects, right? So the tension is same at all the points on the string, right? So these are massless pulleys, so just one tension, right? Tension is same at all the points on the pulleys. So let us consider the pulley P3. Okay, what are the forces acting on this pulley P3? See this pulley P3. So the forces acting on the pulley P3 in the upward direction, that is the tension on the string, right? Tension, right? That is T. So T is in the upward direction. And what about downward direction? So minus T plus T, 2T, right? This side of the string and that part of the string, right? So 2T is the tension in the downward direction. So T minus 2T, but this is the total force acting on that pulley P3, but that must be equal to 0 because the pulley is massless, right? Mass is 0. So that means we are getting the tension 0. So the tension in the string is 0 actually. So this is as good as no string only, right? So no tension, so no force is acting on these blocks, only the gravitational force is acting on the block, right? No tension. So it is like free fall, okay?
The string is taut. Hard to believe that the tension is 0.
See, it is not very intuitive. We come to know that the tension is 0 only after doing this calculation. Take this example to understand this better. There are two blocks of equal mass connected by a string. They are falling under gravity. Now, what is the force acting on that string? So no force is acting on the string, right? There is no force which is stretching the string, because so both of these blocks are falling with the same acceleration. So no force is exerted on the string, right? That means the tension in the string is 0. You understand? So even though it looks like a taut string, tension is 0, right? Because both these blocks are falling under gravity with the same acceleration. So no force is exerted on the string. So that means the tension is 0, right? So same is the case here. Here it is very obvious, but in that case it's a little complicated. You can't guess it. So we have done it using this calculation and we got the tension 0. That means what is the force acting on the block M1? Only the gravitation force. That means the acceleration of that block is just the acceleration due to gravity. That's all, because no tension force in the upward direction, only gravitation force. What about M2? Again gravitation force. So because only gravitation force, no tension, and that is the acceleration of the pulley P2 also, because P2 and M2 are connected, so same acceleration. Okay, so that means both the blocks move under gravity only, so that means acceleration of the mass M1, so that is same as the acceleration due to gravity, that is g. That's it. What about the acceleration of the block M2? So that is also g, because only force is the gravitation force. So that is connected to the block, the pulley P2. So that means the acceleration of the pulley P2. So that is also g. So all these objects move with the same acceleration, right? M1, M2 and P2 move with the same acceleration g in the downward direction. But what about P3, the pulley P3? What is the acceleration of pulley P3? So that is not g, because it is massless, right? So that is massless, so that means it does not fall under gravity. So we have to find its acceleration separately using another method, right? See, that is connected to the string. So what is the acceleration of that part of the string? That's what we need to find. See, we have to use the displacement method. Suppose M1 moves down. Let us take M1 to be moving upward. Actually, it is moving in the downward direction under gravity, but let us take this to be moving in the upward direction. That is easier for our calculation. If M1 moves up by some distance, the string loosens by what length? Same x, right? Because M1 moves up by some distance, so that string loosens. That means P3 will come down by the same distance x. Do you understand? If M1 moves up by some distance, that P3 moves down by the same distance, right? Okay, done. Now what about M2? If M2 moves up by some distance, then the string loosens. The slack part of the string is of length 2 times that, right? 2x, because so x plus x 2x. If M2 moves up, or M2 or the pulley P2, any one of them, right? They move up by the distance x. Then the slack part of the string. So this string slackens by length 2x. That means both of them are moving up. M1 is moving up by x unit. M2 is also moving up by x unit. So then the total length of the string, so that, the distance covered by P3, that is x plus 2x. X because of M1 and then 2x because of M2. So x plus 2x, which means the total length covered by the pulley P3 is x plus x plus x. That is 3x. Do you understand? So the 3 times the acceleration of these two objects, M1 and M2. So that is our required acceleration of P3. Is that okay? See, let me write it. If M1 moves up by distance x, then P2 moves down by distance x. Okay, if M1 moves up by some length, then P3 moves down by the same length x. Okay, now what about M2? If M2 moves up by the distance x, P2 moves down by the length 2x, right? Because that slack part, right, 2x, so that is compensated by P3, right, in the downward direction. Okay, that's all. That means what is the total distance covered by P3? X plus 2x, so that is 3x, which means these two blocks are moving by some distance. Then the pulley P3 moves down by thrice the distance, which means the acceleration of P3 equal to, so x plus 2x, that is 3x. So 3 times the acceleration of g. Okay, so that is the answer, but in the opposite direction. Okay, P3 is moving in the upward direction, because we have taken that these M1 and M2 are moving in the upward direction, so P3 moves in the downward direction. But actually M1 and M2 are moving under gravity. So that means they are moving in the downward direction. So that means P3 will be moving in the upward direction by the same acceleration, 3g. So that's all. So M1, M2, P2 have the acceleration g in the downward direction, but P3 has acceleration 3g in the upward direction. Is that okay? So that is the required answer. If the pulley given in the figure is moving up with acceleration 2 meter per second square, the acceleration of the 4 kilogram block is. This is a simple question in advert machine, but the pulley is moving with an acceleration 2 meter per second square in the upward direction. We have to find the accelerations of these two blocks. Okay, first of all, we will find the relation between the accelerations of these two blocks, right, using the average method. So that is the easiest one here. See, what is the average method here? The average of the accelerations of these two blocks is the acceleration of that pulley, right? So these two strings have acceleration something. The average of that is the acceleration of the middle one, that is the pulley. Okay, yes. Now let us use the average method. So what is the acceleration of this block, 3 kilogram block? So let us take that to be A1 in the upward direction, A1 in the upward direction, and 4 kg block, so that is A2 in the upward direction. We don't know which one is moving upward or downward. Maybe both of them are moving upward, we don't know. But let us take the accelerations to be A1, A2, both of them to be in the upward direction. Okay, then the average of these two is the acceleration of that pulley. Okay, so that means A1 plus A2 divided by 2. So that is the average. So that equals the acceleration of the pulley, which is 2. So we got some relation between these accelerations, right? Yes. So that is 4. Okay. Now let us use the equation now. What are the forces acting on this block? Tension in the upward direction, gravitation force in the downward direction. So that is this 3 kg block. For the 3 kg block, the tension in the upward direction minus gravitation force 3g equals mass times the acceleration, 3 times the acceleration, which is A1. Okay, done. Similarly for the other block, so that block is also moving in the upward direction, so that will give you the tension minus the weight 4g, so that equals 4 times the acceleration A2. Okay, so that's it. So we don't want the tension, so we can eliminate that by subtracting. So shall we subtract these two equations? So t minus t cancels, so that is g equals, so this is 3a1 minus 4a2. Okay, so that's it. But we already have a relation between a1 and a2, so that can be used here. So that equals 3a1 minus 4. What is a2? a2 can be written as 4 minus a1. Okay, so that is g. So let us take the value of g to be 10, right? So approximately we can take this to be 10. So 10 equals, so 10 plus so this is 10 equals 3a1 plus 4a1, so that is 7a1 minus 16, so that gives you the value of a1, right? So a1 equals, so 16 plus 10, so 26 divided by 7. So this is the acceleration of a1, that means the block of mass 3 kilogram. Okay, done. Now similarly you can find a2 by substituting here 4 minus a1, right? What is this one? 4 minus this one, right? That means 28 minus 26, so that is 2 divided by 7. So that's also, these are the accelerations of these two blocks. But see, these two accelerations are positive. That means the directions we had assumed, right? So that is correct only. Suppose you're getting one of them negative, that means that moves in the opposite direction. We had assumed that both these objects were moving in the upward direction, and we got the acceleration positive, which means so they both are moving in the upward direction only. So that means, so these are the accelerations of the block 26 by 7 for this block of mass 3 kg, and a2 2 by 7, that is the acceleration of the other block. Okay, the ball B given in the figure has mass 1.5 times the mass of the rod. The time taken by the ball to lose contact with the rod is. Here two pulleys are there, one of which is a fixed pulley at the top and another pulley, so that is a moving one. Now there are two strings. One string is attached to the ground and the other end is attached to a rod of length L, and then another string is attached to a ball of mass 1.5 times the mass of the rod. Okay, now this is the position. The ball is touching the rod at the lower end. Now we have to find the time taken for these two to lose contact. That means, so this ball has to cover a distance of L, right? This ball should move upwards to cover a distance of L, so that is when it will lose contact, right? So that time we have to find, time taken for that to happen. So that's what we need to find. Okay,
The ball is heavier, that is supposed to move downwards, right?
yeah, the ball is heavier, right? 1.5 times the mass of the rod, but we should not consider only the gravitational force. Also there is a tension force in the upward direction. What about the tension force acting on these two objects? See, let us take the tension on that string that is taken as T, the string that is attached to the ground, so that has tension T. So what is the force acting on that rod? So that is T in the upward direction. Okay. Now what about the tension on the other string? So that is 2T, right? T plus T, 2T, right? T on that side, T on this side. So 2T is the tension on that string which is connected to that ball. Okay. That means the upward tension is twice the tension acting on that rod. So upward force is more. You understand? The downward gravitational force is just 1.5 times, but the upward force is 2 times. So that is why the ball is moving in the upward direction and the rod is moving in the downward direction. Okay. Yes, let us find the relation between these two accelerations. Let us use the tension method, right? That is the easier one here. So what is the tension acting on that rod? The rod is in the downward direction. So that is, yes, so that is T. T is the tension acting on the rod. Okay, multiply by its acceleration. So that is taken as acceleration of that A, right? The rod A. So that is this one. Okay. Now the tension is acting in the opposite direction. Tension is acting in the upward direction, but rod is in the downward direction. So we can take minus. Okay. So opposite directions. Okay. Now similarly for the other object. So that is the ball B. So that has tension 2T. So plus 2T multiplied by the acceleration of that, so that is AB. So this total equal to 0. So that gives you the relation. So if you cancel this, so the acceleration A, so that equals 2 times the acceleration of B. Okay, so that's all. So this relation can be used later. Now let us use our equations. So what are the forces acting on the ball, right? So that is the tension in the upward direction and also the gravitation force in the downward direction. So the ball. So the tension in the upward direction, but the tension is 2T minus gravitation force in the downward direction. So the mass is taken as 1.5 times the mass of the rod, right? Mass of the rod is m. So this is 1.5 times m. So 1.5 times m multiplied by g, that equals mass 1.5 multiplied by the acceleration of b. Okay, so this is one equation. Okay. Now similarly for that rod. So what are the force? That is moving in the downward direction. So gravitation force first, right? So that is mg minus tension in the upward direction, that equals mass times acceleration. So m multiplied by the acceleration a. Okay, yes. So done. Now we simply have to solve it. We already have a relation between these two. So that can also be used here. Yes. Now we don't want this tension, right? So we have to eliminate this tension. So how will you solve these two equations? So let's eliminate tension. So we multiply this equation by 2 and then add. Okay, if you 2t, that will get cancelled. Multiply by this by 2. So 2 mg is minus 1.5 mg, which means 0.5 mg. Okay, I'm directly writing. So here, this is multiplied by 2. So that is 2m acceleration of A, and that is added. So plus 1.5 m. Okay, I think I missed m here. So 1.5 m. 1.5 m is the mass of the object, right? So mass times the acceleration. So m multiplied by acceleration of B. So 1.5 m acceleration of B. Yes. Okay, done. So m can be divided. So if you divide by m, so we get and multiply by 2 also. If you multiply by 2, so we'll get what do you get? G equals 4 times the acceleration of A. So this is multiplied by 2. So it is 3. Acceleration of B, but what is acceleration of B? Acceleration of A divided by 2, right? So that means acceleration of A divided by 2. So that gives you the required acceleration. So this gives you, so what is the value? This G equals, so this is 8 plus 3, so 11 times acceleration of A divided by 2. So that gives you our required acceleration of A. So that is 2G divided by 11. Okay, done. Similarly, what is acceleration of B then? So acceleration of A is known, right? 2g divided by 11. So that means acceleration of B is simply g divided by 11. See, we don't want the accelerations of these two objects. We want the relative acceleration, because what is the distance to be covered by the ball? Not L. Because by the time the B reaches the top of the rod, that rod also comes down by some distance, right? That means the total distance covered by B is not L. Okay, it is only the relative distance, because when B moves up by distance L, the rod will also come down by the distance L, right? This is some distance, right? That means we don't want to cover that total length L, only the relative length right? The relative distance to be covered is L. That means we have to find the relative acceleration. So what is the relative acceleration here? So these objects are moving in the opposite direction. Okay, the relative acceleration is simply you have to add these two, right? Because opposite direction, so we have to add these two acceleration, which is 3g divided by 11, right? So 3g divided by 11. This is the relative acceleration, but what we need is the distance. So that is only the relative distance. So the relative distance to be covered, so that is L. Okay, L is the relative distance. Okay, now done. The distance is known and also the acceleration is known. So we have to find the time. So we use our basic equations of motion. S equal to ut plus half at squared. Okay, let's use this equation. So S equals ut plus half at squared. So S is the distance to be covered, L, and initial speed is 0 plus half the acceleration. So the acceleration is what we have found here. So 3g divided by 11. So 3g by 11 multiply by t square, that will give you the value of t. So that is, what do you get? So this is 22L divided by 3g. So that's all. So 22L divided by 3g. So square root of that. So that is our required time taken for the ball to reach the top. That means the relative distance covered is L. So when it reaches the top of the rod, they lose contact, right? So that's all. So that is the time taken, which is 22L by 3g under root, right? So that is the answer. Find the acceleration of the man given in the figure when he is at rest relative to the rope, and also find the acceleration of the man when the block of mass 5m is at rest. Here so many pulleys are there, right? So we have to consider these three objects. One is a block of mass 2m which is placed on the inclined plane, and the other one is a block of mass 5m which is connected to the strings, and also we have a man of mass m, so who is holding on to the rope, right? So in the first case, the man is not trying anything, right? He is not trying to climb up or anything. He is just holding on to the rope. So that means the acceleration of the man is same as the acceleration of that part of the rope, right? Yes. So that is one thing. Now we have to first find the relation between the accelerations of these three objects, right? Let us use the tension method, right? So what is the tension force acting on the man? See, let us take this is just one string, right? So one string that connects all these objects, right? That means so tension on that string, so that is taken as T. So T is the tension force acting on the man. So that means T multiplied by acceleration of the man. So that is T is the tension force. Let us first take the acceleration to be in the upward direction. We don't know which object is moving upward, which one is moving downwards, but let us take initially all of them to be moving in the upward direction. So tension in the upward direction, the man is also moving in the upward direction. That means T multiplied by the acceleration of the man. So the acceleration of the man of mass m, so that is taken as T multiplied by m. Okay, so that's it. And then this block, okay, on the inclined plane, so that tension force is T only again. So T multiplied by plus T multiplied by the acceleration of that mass is 2m. So take it as acceleration 2m. Okay, now similarly, what is the tension force acting on this block of mass 5m? So see, this block, right, this string has tension T, this string which connects all these objects. But now what is the total tension acting on this block? So that is T, right, T plus T, 2T, right, T plus T, 2T, and plus T plus T. How many strings are attached to that? So attached to the pulleys, right? So T plus T, 2T, first pulley, T plus T, 2T, again 2T in the second pulley, and T plus T, 2T, third pulley. So that means totally 6T. 6T is the total tension force acting on this block of mass 5m, right? So 6T multiplied by its acceleration. So it is 6T multiplied by the acceleration of that block having mass 5m. So this total is 0. Okay, so this is the relation between the acceleration. If you divide by T, am plus, okay, so a 2m plus 6a 5m equals 0. Okay, so that's all. So this is the relation. Okay, now let us consider these objects one by one. Okay, yes. Now the man, okay, the man, he is moving upwards. That means tension force is this is for the man, the man of mass m. Okay, so m. So the tension force in the upward direction minus mg in the downward direction, that equals the mass times the acceleration of the man. Okay, so that is for the man. Now this block, so this block, what is the tension force? T only, so 2m. For this 2m block, the tension force is T along the incline minus the gravitational force, but gravitational force is acting in the downward direction. Okay, downward direction, but you have to take its component along its motion. So that angle is, this is 30, right? That angle is 30 degree, right? That angle is 60 degree with the vertical. So take its component mg cos 60, right, mg cos 60, right, so that is 2 mg here, 2 mg cos 60, we are taking the component, so that equals mass is 2m multiplied by the acceleration of the object is this. Okay, now similarly that 5m block, so that has tension totally 60, right, 60 is the total tension minus its weight, that is 5m multiplied by g, so that equals mass times the acceleration, that is 5m acceleration of this 5m. Okay, so that's all. So these are the three equations. You have to solve these three equations to get our required acceleration. Okay, so how will you solve these three equations? You have to substitute these values. Okay, so here you have to substitute. Okay, so what is am? So that can be substituted here. Similarly, a2m, a5m. Substitute all these values here in this equation, so we will get the answer. Okay, yes, what do we do? So am, so what is the am value? So am here is t minus mg divided by m. Okay, yes. Similarly, a2m, so a2m from this is plus t minus 2 mg cos 60. Cos 60 is 1 by 2. Okay, is 2 mg multiplied by 1 by 2 divided by 2m. Similarly, last one, right, 6 times a5m, so that is plus 6 times a5m. So yeah, so a5m is this one, so 60 minus 5 mg divided by 5m, so that total is equal to 0. Okay, so we have to solve this equation to get our required answer. Okay, so let us, you can multiply by m. Okay, m here, so that you can multiply, so t if you take out, so that will become, so it is 1 and here it is 1 by 2, and t if you take common, so this is 36 divided by 5, so that is 36 divided by 5. So similarly mg, okay, so if you take mg, so that equals mg multiplied by, so what is the value? This is 1, this is 1 by 2 plus 1 by 2, and here we have 6 multiplied by 5, so that is, okay, 6, okay, 5 gets cancelled, so this is plus 6, so that's it. So we simplify this, so that will give you t multiplied by, okay, if you multiply this by 10, so this is 10 plus 5, 15, 15 plus 72, so that is 15 plus 72, right, so it is 87, so 87 divided by 10, so that equals mg multiplied by, okay, so what is this? So this is 12 plus 1, 13 plus 2, so 15 divided by 2. Okay, so that will give you our required tension, so tension is equal to, so mg, so if you cross multiply, so that is 5 times 15, so it is 75 mg divided by 87, so that is the tension in that string. Okay, tension, t is found. Once t is found, we can substitute here to get the value of the acceleration of the man, right? Yes, that's it. So this gives you the acceleration of the man, so that is am, so that is t minus mg, so this value minus mg, so that means 75 minus 87, so that is minus 12 mg divided by 87, so that is the acceleration of the man. Now we'll consider the second question. So this is the first one. Okay, so the second one, see here, now the 5m block is at rest. Okay, so that means what is the total force acting on the 5m block? So this a5m, so that equals 0. Okay, so the 5m block is at rest. What is the total force acting on the block? 60 in the upward direction and the gravitation force in the downward direction, so 60, right, minus the gravitation force, that is 5 mg, so this is the total force, so that must be equal to 0. Okay, so this gives you the tension T equal to 5 mg divided by 6. So this is the tension when this is at rest, this block is at rest. Now we have to find the acceleration of the man. So this time the man is not at rest with respect to the rope. Okay, he is climbing up with some acceleration. That acceleration we have to find. So what is the acceleration of the man? So the tension in the upward direction. So for this man, okay, so for this man M, what is the tension in the upward direction T, and then downward gravitation force minus mg equals, so mass of the man, that is m, multiplied by the acceleration of the man, so that is am. But the tension is found already, 5 mg divided by 6, so 5 mg divided by 6 minus mg equals m acceleration of m. So that gives you our required acceleration of m, so that equals, so what is this value? So yeah, minus g by 6, so that is the answer, minus g by 6, that is the acceleration. So it is negative, that means actually he is climbing down, right? So he is moving downwards, right? He is moving down the rope. I don't know how the physics works, right? He is not climbing up, right? To keep this rod, keep this block in equilibrium, so he has to go down with acceleration minus g by 6, right? He is moving down the rope with acceleration minus g by 6. That is the answer to the second question. Okay, this is m times am, right? So m multiplied by am, that is t minus mg, right? So that is minus 12 mg divided by 87. So to find am, you have to divide by m also. So if you divide this by m, okay, so this gets cancelled. Okay, so that means minus 12g divided by 87, that is the acceleration of the man in the first case. In the second case, the acceleration is minus g by 6, right? So that's all. So that is the answer. The pulley given in the figure is moved horizontally by the force F. The acceleration of the block is. Here a force F acts on the pulley in the horizontal direction. So as a result, this block will also move in the upward direction. So we have to find the acceleration of that block. But the block moves in the upward direction. Not only that, it will also move in the horizontal direction. So the acceleration is somewhat inclined to the horizontal with some angle, right? So we have to find the vertical acceleration and also the horizontal acceleration of this block. Okay, see, this horizontal acceleration of this block is same as the horizontal acceleration of the pulley, right? Yes. Now the vertical acceleration, that you have to find. Okay, so what will happen? So let us use the variable method, right? So to find the relation between the acceleration, let us use the variable method. Let us take this part of the string has length, right, say x, and this has length y. So x plus y is the total length of the string. So that means x plus y is constant. That is the total length of the string, that is constant, right? Let us differentiate this. So dx by dt plus dy by dt, right? So that is the derivative, so that equals to 0. But what is dx by dt? That is the acceleration of the pulley, right? As x increases, that pulley moves in the forward direction. So that means dx by dt is the acceleration of the pulley. Okay, right? I mean, it's the velocity of the pulley. Now we can differentiate again to get the acceleration. So acceleration of the pulley. Then dy by dt. What is dy by dt? That is the acceleration of the block in the vertical direction, but negative, because y decreases. When the block moves in the upward direction, y decreases. That means it is negative of the velocity, negative of the velocity of the block. Differentiate again, you will get acceleration. So this is acceleration of the block m. It is not the acceleration of the block m, only the vertical acceleration. Now we also have to find the horizontal acceleration, that we can do later. So this is only the vertical acceleration of the pulley, right? So this total equals 0. Okay, so remember, this is only the vertical acceleration of the block. Okay, yes, so vertical acceleration. Okay, done. Now we have to find this value of this, right? So let us find this. So what are the forces acting on the block? So that is tension in the upward direction, gravitational force. So for the block m, the tension in the upward direction, so that is T, minus mg in the downward direction, so that equals total mass multiplied by the acceleration, that is am. That is same as the acceleration of the pulley only. Okay, yes. Similarly, now but for the pulley, what are the forces acting on the pulley? So that is the force F is acting in this direction. Okay, force F. Similarly, tension is acting in the negative direction, right? F and tension, so F minus T. So that is the total force, F minus T. But that must be equal to 0. So that is an ideal pulley. So the mass is 0, F minus T equals 0. That means tension is same as the force, the applied force F. Okay, so that's all. So that is one thing. Now we can solve these equations to get the value of this AM. Okay, so let us find it. So yeah. So simplify this. So at T minus mg equal to m times acceleration of m, but acceleration of m is same as the acceleration of the pulley. Okay, so that means if you simplify, so this is T. Okay, that is same as F. So F minus mg equals m acceleration of m. So that gives you the required acceleration am. So that is F minus mg divided by this m. This is the acceleration only in the vertical direction. Now we have to find the acceleration in the horizontal direction. So actually this block moves in two directions. One in the upward direction, that is the acceleration am. Okay, that is the acceleration of the pulley only. Now the acceleration am in the upward direction, that's what we have found here. Now the horizontal acceleration. The horizontal acceleration is same as the acceleration of the pulley only, right? The pulley moves in this direction due to that force F, and similarly the mass m will also move in the horizontal direction with the same acceleration. So that's it. Now what do we have to find? We have to find the resultant. So what is the resultant of this? You know, right? So two perpendicular directions, so you have to find the resultant of the vector. This is square root of this one, square root of this square plus this square, right? So am square plus ab square, right? So to find the resultant of these two, or if you use the geometry, right, this is am, this is ap, hypotenuse, using Pythagoras theorem we can find it. So am is found, so that ap, but ap is same as am only, right? So ap is same as am only, so that means, so this equals square root of am square plus ap is same as am, so am square. So that's all, which means 2 times am square, so root, so that means this is am multiplied by root 2. So that's all, this is the total acceleration, right? Am multiplied by root 2, that is the acceleration of that required block. So that means, so that implies our required acceleration equals root 2 multiplied by am, but am is already found, so that means root 2 multiplied by am. Am is simply f minus mg divided by this m. So that's all. So this is the total acceleration. Do you understand? So this block is moving in two directions, right? So there are two components for the acceleration. So one in the vertical direction, that we have done using our this one, right? So we have used this method this time, so the variable method. Okay, so that is easier here. Okay, similarly it also has the horizontal acceleration, which is same as the acceleration of the pulley itself. So that means, so combining them, so we get this answer, root 2 multiplied by f minus mg divided by m. So that is the answer. We're done with all aspects of the tension force. In the next class we're going to talk about spring force. Okay.